North Africa. 1942. The sun is, well, merciless. Metal burns to the touch. Water spoils in just a few hours. Engines overheat. Men collapse from heat stroke. And yet, hidden in plain sight, Allied troops were using a low-tech cooling method so effective, so simple, that it kept water drinkable in 120-degree heat, without electricity, without ice, without moving parts. Some called it a trick. Others called it a miracle. Today, most campers don't even know it existed. During the North African campaign of World War II, from the brutal battles at El Alamein to desert operations in Libya, soldiers faced a relentless enemy beyond bullets and bombs: heat. The British 8th Army, German Afrika Korps. Supply lines stretched thin across endless sand. Refrigeration? Rare. Ice? A fantasy. But water was survival. And someone remembered something ancient. It wasn't invented in the 1940s. It wasn't developed in a laboratory. It didn't require a patent. It was based on a principle older than Rome, older than empire: evaporative cooling, specifically the Zier pot system, also known as the pot-in-pot refrigerator. 2 clay pots, one inside the other. Sand between them. Water poured into the sand. A damp cloth over the top. That's it. As water in the sand slowly evaporates through the outer clay pot, it pulls heat away from the inner chamber. No power source, no batteries, no compressor, just physics. And in the dry desert air of North Africa, it worked astonishingly well. When water evaporates, it absorbs energy, heat energy, from its surroundings. That energy transfer cools whatever remains. The drier the air, the better it works. In desert conditions, temperatures inside a Zier system can drop 20 to 40 degrees Fahrenheit below ambient air. Let that sink in for a moment. If it's 110 degrees outside, your stored food could sit at 70 or even 65 degrees. In 1942, that wasn't convenience. That was survival. British troops stationed in desert outposts used variations of this method to keep drinking water, cooler vegetables from rotting medical supplies, from degrading rations, from spoiling. And here's the fascinating part. It wasn't a new invention. It was knowledge rediscovered. Versions of evaporative clay cooling were used in ancient Egypt, Persia, and across Africa for thousands of years. But in the Second World War, modern mechanized armies, tanks, radios, aircraft, turned back to a primitive technology because it worked. So why don't modern campers use it? Why do we haul 40-pound electric coolers into the woods, strap solar panels to backpacks, buy expensive compressor fridges for overlanding rigs, when, honestly, 2 clay pots and a bag of sand can drop temperatures dramatically? Here's the uncomfortable truth. We forgot how to live with physics. We outsourced comfort to electricity, and in doing so, we lost resilience. Evaporative cooling doesn't just work in deserts. It works in any dry climate. The American Southwest, high-altitude mountain regions, arid plains. It requires airflow, low humidity, porous clay, water. That's it. No cords, no noise, no lithium batteries. But there's a catch. It doesn't work well in humid environments. In places like Florida or Southeast Asia, where air is already saturated with moisture, evaporation slows, Cooling drops dramatically, which may be one reason the trick faded in mainstream outdoor culture. Are humid, but in dry climates, it's almost magical. Picture this. You're deep in the Arizona backcountry, 95 degrees at sunset. Your ice has melted, your power station battery is dying. Now imagine instead a clay system sitting in the shade, outer pot sweating slightly, a faint coolness radiating from its surface. Inside, tomatoes firm, cheese holding shape, water refreshingly cool, all powered by evaporation. During the Second World War desert campaigns, simplicity was strength. Complex machines, well, they failed. Sand-jammed engines, supply chains broke down. But clay, sand, water, they were everywhere. The ZIA system required no maintenance beyond just adding water. No moving parts meant, honestly, nothing to break. It was anti-fragile. Consider the Battle of El Alamein again. Temperatures soared, men fainted, heat-stroke casualties mounted. Logistics officers weren't just fighting enemy forces, they were fighting entropy itself. Spoiled rations meant weakened soldiers. Warm water meant dehydration. Dehydration meant collapse. Cooling wasn't about comfort. It was about combat readiness. And sometimes the solution wasn't high-tech at all. It was ancient. There's something, I think, rather poetic about this. Industrial war, saved in part by primitive design. In a century obsessed with mechanization, the answer was porous earth and airflow. Which raises a question, doesn't it? What other low-tech survival knowledge have we quietly abandoned? If you wanted to build one today, here's the distilled process. Get 2 unglazed clay pots, one just a bit smaller than the other. Place sand between them, saturate the sand with water, cover the top with a damp cloth. Keep it in a breezy, shaded spot. Re-wet as needed. That's it, really. In ideal conditions, internal temperatures can rival modern passive coolers, and all without ice. But here's where it becomes more than a camping hack, you see. It's about decentralization. During wartime, supply lines can fail. Power grids can collapse. Refrigeration depends on infrastructure. Evaporative cooling depends on climate. It's a reminder that resilience often hides in simplicity. Today, preppers talk about grid-down scenarios, solar storms, infrastructure fragility. Yet few discuss the practical cooling strategies that actually sustained armies in one of history's harshest theatres. We romanticize Second World War technology, the tanks, the aircraft, the radar systems, but sometimes survival hinged on 2 clay pots and wet sand. So the next time you pack a high-tech cooler for a desert camping trip, ask yourself, are you carrying innovation or just forgetting history? In 1942, under the same sun that rises today, soldiers in North Africa drank cooled water from clay systems that required nothing but physics. No charging cables, no compressor hum, no melting ice anxiety, just evaporation, the quiet transfer of heat into air. It wasn't flashy, it wasn't patented, it didn't trend, but it worked. And sometimes the most powerful technology isn't new, it's remembered. If this changed how you think about survival gear, just imagine what else history is hiding in plain sight. Because the desert remembers. Do we?